protest, but it turned out the mate of mine said that the traffic flowed actually quite nicely, because normally on coming in from the northern, it comes to a halt, then you go, then you halt, then you go, whereas they came on and they went at a very even pace, which actually turned out to be really good for the traffic. But I don't know if it was the same all around Auckland. Some of it was a bit tilted. So yeah, that wasn't the reason why today's the lecture was cancelled. Well, not cancelled. We don't have a lecture for the last two, to give you some time to do your drawings and kind of start to catch up with where you should be. Some of you have got other subjects you're doing where you've got pretty heavy workload as well. So I'll hang around after I've done the revision, and if you want to ask some questions, the two of us will be here to do that. If you want to ask something about the revision, that's fine as well. About every, I don't know, maybe every fourth or fifth year we do a bridge. Slightly different in length and sizes and stuff, but the concept's the same.
What's that, buddy?
And the reinforcing is the bridge abutment. And that's basically what we're going to be doing in the test, a bridge abutment. But I thought it would only be fair of me to go over an example of one in class, so that you had the concept in your brain when you were doing the questions. I've got them done again. I can't believe it. Never mind. Marker pens. Yeah, I've got 1,000 pens this week and no marker pens. So you've got your famous one here. Good one. Okay, hopefully it works. If not, you might have to go and pinch another room. So with a bridge, I don't know if you know that much about bridges, but we often have a situation where you've got a pier in the middle and raking piles going like that. You've got your ground that comes up sort of like this, and then you have another thing here called an abutment, which looks very similar to that. The bridge beams sit between there and there, and this might be made up of different roading surfaces coming in towards the bridge, and then you have another one going over towards an abutment on the other side. So this abutment here is basically the first thing I ever did in engineering. When I got a job in the office, they gave me a simple little abutment. It turned out to be not that simple. It was for a bridge that goes across the Clutha River at Cromwell. It's quite a long bridge. I just did one of the abutments on one side, which was quite cool because I got a site visit to that one and another one at Queenstown out of it from the Dunedin office. 2 or 3 days staying in motels in Queenstown and Cromwell wasn't exactly hard work. But the actual doing of the abutment, drawing up of the abutment was fairly complex. So I've made your one a lot more simple, so don't worry too much about that. But it is a concept you'll need to get your head around today in terms of the abutment. You'll get about 3 or 4 abutment reinforcing questions out of 20. So it's not like you can stuff that up completely but still get a good mark. remember that mark ends up out of 10. But at the same time, if you get the concept, it's money for January, as they say. We will also go over that steel diagram that we did last time, just to reinforce it for your assignment too, because some of you may be getting to the tail end of doing those quantities and going, oh, I think I might have done something wrong, right? Or, okay, it's just a big fact that I've done that right. And of course, there'll be a couple of questions on that in the test. And plate design, which turns out to be a little bit harder than you think. And I'll give you a super easy one, a medium easy one, and a harder one. And the ones in the test are all over the place. And I've kind of said to Moodle, give you one hard one easy one, and whatever. Although students have come up to me and said, oh, Moodle gave me 2 easy ones. It's my concept of what's hard, not necessarily yours, okay? And of course there'll be the usual multi-choice, which I can't help you with. You'll have to read through the notes. It will be online, so that's a bonus. If you can power through these mathematical ones quickly, you'll have all the time in the world to look up the answers on the other one. Otherwise, if you don't, you need to know exactly what page to turn to. I look at it this way: if you do your homework, you do your revision, you should be able to do about 16 of them without thinking too hard. And the other 4, that's when you do the look-up thing, because you just can't remember what the answer to that is or whatever here. You can sit the test anywhere you like. It's not done under supervision, so you can come in here to do it next week in the lab if you want to. You can do it at home in your pyjamas if you want to. You can do it in the over there in the hub. Just don't do it in your pyjamas in the hub. I'll be doing it from where am I going to be? I'm going to be at home doing that, but I'll stay on there after the test because hand-in's the next Friday. So you've still got a pass tutorial that's available on the Friday. Sorry, the hand-in's on the Sunday. But I'll stay online after the test. If somebody wants to share their drawings and ask questions, then that's fine. We'll start limiting it to 1 per person, but if other people aren't interested, then we'll keep it at, we'll let that person ask more questions. If you've not done that before, it's quite a good way of getting, you share your screen, and I actually just write on top of it, say I'll move that over there, or check that distance, or whatever. But a lot of people say it's not fair. The ones that shared their screen got good tips, and I didn't get any. Well, actually, you're actually getting tips off that anyway, So, so we'll do that next week. There's no lecture next week. That'll give you some time to do some revision for the test in the afternoon, or anything else that you have to do. Up to you. All right. So this is what we'll look at when we get round to it today, and. You would have already seen online questions that are typical of what I'm actually going to go over. So just give us a second, I'll pull down the screen, we'll get sorted. It just takes a couple of seconds on here to get the system going. So I don't know if any of you noticed to pass the paper you must attempt everything, every assessment. They're getting around, teachers are getting around it a little bit by putting 2 assessments in one. So your mark for the tests, for example, both tests will be a combined number, which I'll put in to Moodle, so that if you've missed one you can still pass the course. But generally speaking, just be very careful of that, because some teachers still have it divided into assessment. It goes into Moodle. You got a 0 for that, you might get 99 for the other 2. You won't pass the course. It's just the rules of the degree degree zone is strict for some reason. I'm not sure why, but that's the way it is. Yeah. And I don't think I'll get you as a class together after this either, so apart from online. So just remember, if you do get 60% or better for this course, which is 65% or better, which is a B minus. All right, you can, as long as you can prove that to Edward, and he's happy and there's positions available, you can do detailing and modelling. All right.
As a diploma student?
As a diploma elective, yes.
Okay.
So it is actually, that means there'll be one of the other papers you don't have to do. It's also, for those that are New Zealand residents, it's also student loan and all the reason, so it's quite good like that. And the only thing that I would say is maybe give it a semester before you do it, because it's a little bit like a huge project. If you jump into it in your first year here at Unitec, it's bloody hard. It is, because it's combining things you haven't done. Whereas detailing and modelling, you'll probably find Revit okay, but you start getting into the 12D and you're doing geometry of roads and all sorts of things that you may not have done, and it just goes while they're talking away, and you're not even getting a chance to press the right button. So that's the feedback I've had, that if you've been here for maybe a year and a half, no problem at all. Would that be right? You're doing 12D, aren't you?
Grace?
Yeah, Grace? You're doing 12D, aren't you?
Yeah, that's right.
Oh, sorry.
12D and the rivet.
Yeah, but it is touching on a lot of stuff that you, design stuff that you should have known from other subjects.
Yes, like you should learn something about the highway,
Yes.
how to design the road,
Yeah.
horizontal, vertical.
Vertical and horizontal curves.
Yeah.
Yeah.
That's the knowledge you should have. But you still will learn this part during the 12D learning.
Yeah, Amanda will touch on it. She was one of my better students in design and drawing, which is like civil and structural drawing. She knows that she has to teach you something, to transition you through. She's very good, actually. She's an ex-student and been in the industry for about 2 or 10 years now, I think, something like that, using both of the program. Okay, let's get this show on the road.
is a moving bit. Where is it? 16.
Okay, so we have plate design. I'll just turn this off a little bit. So when I go over the answers to these, is it okay still for seeing whatever's your hands, where your hands are? Alright, when I go over the answer for these, it'll become very obvious that I'm trying my best to push the holes as close to the edge as I possibly can. So you'll see that, and hopefully you've also done that on your assignment where possible. No use pushing them to the edge if they don't actually work. It doesn't actually work. The only difference in your assignment is you have got kind of like the letter H on top of that, which is your column, which is welded to it, and you need to steer clear of that a little bit. So we've got the first one is a reasonably straightforward one. Then we introduce another one of the rules, and then we introduce the third rule. Secondly, of course, is the old girder, and I just need to go over a couple of things with this. Now, it'll look very much like that when you come to do it in the test, but there'll be different numbers there for the top member, the beam, and the two angles either side. Also, the weights might be different, and one thing to be very careful of is how long it is. Here it is 12 metres. That changes considerably in the test. Don't think they're all 12 metres, otherwise you'll come out of wonky. With everything that you do in terms of the subject, it's important to make sure that you put it in either millimetres or metres, and if you are not given decimal places, then make it the same as the other ones on the chart. Okay? So in this particular case, we're talking about a abutment, and this is exactly what the assignment's going to look like. So forget the steel schedule up the top. You're looking at this, and you'll be asked for one of these letters. So in the case of 1601, you do need to take note of these bars here and how they're placed, because they'll be exactly the same in the test. So if you want to draw yourself a little sketch now that you can have beside you while you're doing the test, that's absolutely fine. But I don't want anyone saying to me on the day, "Oh, I can't work out where each of the bars go." It's a bit of a blurry sketch, but you have a bar that goes from here down to this line here. You have a bar that overlaps with it and comes around and goes down. Then there's a U bar that goes that way, and a U end on this side. You have another lapping bar that goes along and down, and this one starts bang on in line with here and goes up. The cover will be at the top but not at the bottom. The actual distances are here. The bar labels are here. Take note of which one they're pointing to. It'll be exactly the same. In the test, these numbers will vary. The bending allowance may not. The cover may not, but it probably will. The bar centres may or may not. keep an eye out. There are a couple where you may need to change the centres. So they may be 250 and 300 centres. So there may be a need to change that, like the assignment and hint. And the width of the abutment is, of course, the length that goes that way. Now, what that would be on the bridge over there, if I'm able to get, here it is in the pocket of it, yeah. Always find something in the pocket if we see look it. So the width of the abutment is this distance that way. So if you think of a road going over the bridge, it's basically the width of the road. Alright? So when it says 3.7, that's probably a pretty reasonable size width for a road, one way. So the width is not what you think, it's not that, it's that way. Easy to make that mistake when you do the calculations. So 3.7 is the width of the one we're doing today. That will change. Here we go, something different. In your assignment, you were given the laps for each bar. I'm making you use 32 times the bar diameter. Now be very careful. In the case of one of the questions, you may not get this question, but in the case of one of them, you've got different bars sizes overlapping. They're all the same size, 16, but you might have a 16 and a 12. So remember, you always go for the 16 or the longer lap. So it'll be 32 times the 16 bar in that case. And yeah, we're trying to push, so there is a lot of similarities between this and your assignment. This looks very familiar to you. The bars get pushed to the outer edge of the going over that, and some of you might go, oh, I've done the assignment wrong, or it's another way of saying big tick I've nailed that. Okay. And that's it. That's the mathematical side of it. There should be at least 10, maybe 12 questions exactly like that, give or take the numbers. And 9 questions, 3 from each section of the note. So 9 concrete, 9 structural steel, and 9 structural timber. Okay? Sorry, 3, 9 of you. Yeah. What I will do as an absolute bonus is that last year's average was 12 out of 20 of those that sat. If you don't get to 12, I'll make the average 12. But I won't be using one of those fancy formulas that curves everybody's number so that it all sort of ends up at an average of 12. I'll just simply, if your average is 11, I'll add a mark. So I think this class will probably do better than that this time around. We'll see how we get on. Because you did better than that in the structural one, the civil ones. Okay, so I'll now earn my money, and hopefully you'll be able to either record it or understand it. And we'll start with the easy stuff, which is the plates. And we'll work our way through to the more difficult ones. So the plates, I'll zoom in on this. And they're out there. This one doesn't need much writing, but it needs a little bit of explanation. So So we always start off by working out our minimum and our maximum. Now it says up there 16mm bolt hole. First mistake students think is that it is a 16mm bolt. It's not. It's a 16mm bolt hole. So therefore the bolt is
50.
no. If you first, that is the second mistake.
Yeah.
15 is only 1 mil,
Yeah.
but it's 1 mil right round, so 14. So 14 mils goes there, times 2.5 equals 35 millimetres. So if you print these out to have beside you in the test, make sure you put a circle around that bolt there at the top saying that that's the bolt hole, not the bolt. The maximum is what we call 32T. In this case it's 32 times the thickness, and the plate thickness is 8, so 32 times 8 is 256. Now we all know that the second rule is that greater than 300? No, it's not. So 256 is your greatest distance, but we're not worried about that just at the moment. What we're worried about is pushing those holes as close from the centre line to the outer edge of the plate is 35 mils. Now when we do that, we end up with B, D and D all equal 35, and we look at what's left over and divide it by 2, and we're within the parameters of the 256. So that's why I say that's an easy one, because if you're asked for B, D, A or C, it's a relatively simple calculation. Now, Moodle could turn over that same plate back at you and ask for C rather than B the second time round. At this stage, it's never asked anyone for the same letter, but it could happen. But be careful, because it does mess around a little bit with the letters. Now, notice this is in millimetres. I don't want millimetres in the answer. I just want the 35 in the answer. So all plates are in millimetres. In terms of my test, in terms of scheduling the plate in the next part, it's always put in metres. Alright? So for this one, I want millimetres, so just 35, 35, 215 or 165. It's important, because if you don't, Moodle will be like, oh, I don't understand, no half mark. The next one is similar but same but different. Okay, I think you can see the A and D along the top there, it's close enough. Yeah. Same but different, eh? It brings back memories of travelling through Southeast Asia buying t-shirts, and they'd always bring one out of the drawer that was going to cost more, because it's the same but different. Build the English that they knew, plus they could count to 10. Roger got ripped off all the time. So we've got a similar situation here. We've got 10mm thick plate this time. So when you multiply 10 by 32, it comes to 320. Now we can't use 320 because we know the rule for the maximum is 300. Good idea to circle that on your model answers, because you will get a number of plates which are 10mm thick. Just to test that you, and one of them actually gets pretty close to those numbers. In this case, we've done the same thing. A up the top there divided by 2 is 240, so that's miles away from 300, and C is 213 because there's 3 of them, so we don't have an issue there. But I can hear everybody saying to me, But what if they do actually go more than the number that they're supposed to? Well, I'll show you what you need to do. This next one explains it. Break 3. Alright, so once again a 10mm thick plate. So 320 or actually 300 is our max. The minimum is 14 times 2.5. So we make everything 35. So with D it works okay, because when we divide that by 3 to get our C, we end up with 213.3, which is well less than that. Where the problem is in that direction, when we divide, we put our 35 down, we make B 35, and we put, we divide what's left over, it doesn't work, it's too big. So 780 minus 35 minus 35 divided by 2 is too big. So we have to go the other way around, and we take our 300 and we put it there and we put it there, and whatever's left, which is 90mm, is what B ends up. Okay? So initially it was easy, we just went to 35. Now it's slightly harder, because if we do that one this way, 780 minus 35 minus 35, so 780 minus 70 equals 710 divided by 2, 355, which is too big for here. So instead, forget those calcs. Now what we're going to do is we're going to put the 300 in there and there. So that makes 780 minus 600.
Now this instead of 35, we're doing 300 now.
We forget the 35. We're
So
going to try
we
and...
don't use 35 anymore. We use
No, we use the very minimum we can, which is 90. Yeah, and that does confuse a lot of people. And you will get a couple of those in the test. Those type of plates. And I think some of you are struggling through your assignment trying to get the holes in the right place as well. Someone was asking me the other day, oh, I can't put the hole here and I can't put the hole there, you know. So you do have to sort of use a little bit of that logic in the assignment as well. Okay, quick recap. First two are quite easy. We're using 35, and then we just see what the number comes to at the end. The last one was trickier. Can't use 35, so we put the maximum in, and we see what's left over and divide that by 2. The answers are in millimetres. The important things to remember are the bolt hole and the maximum drops from 320 to 300. Right, the dreaded girder. Okay, a quick recap of this. You've all got this in your answers anyway from the lab that we did. If you get A, then I'd say that's real easy. I'd say thank you very much, God, for giving me A. Because A is just the length of the beam, which in this case is 12 metres. So that would be 12, right? Mass. The mass is given to you as per metre as 46. Exactly right, it's that little number there. Same with that, it's 122. So that one will be 122. That will be 12, so 12, 12, 122, 122. So if you only get those questioned on the top 4, then, you know, someone's being nice to you that day. But Moodle could start to get a bit more annoying and make you actually go that times that times that equals n, or that times that times that times that equals j. One thing to be careful of is keep the whole number in your calculator each time. Don't round it off and then multiply it by another rounded off number by another rounded off number, because when you get to that point, too much rounding and your answer won't equal Moodle's answer. That's a good tip actually. I remember I had a maths teacher when I was 10 years old at this primary school, and he never had anyone get 100% in his exam. And I actually, well, let's say this, in my opinion I got 100%, but in his opinion I rounded off the last number on the last question by 1 decimal place, and he made it 99%. So he kept up his record for the time he was a primary school teacher. So there was 2 things he was good at. One was maths and the other one was giving the cane, which most of you probably don't know about because you've come from a different country. Sorry, not the cane, the strap. Yeah, in those days, under 10-year-olds would get on the hand, and over 12-year-olds would get it on the backside. Yeah, so he was pretty good at giving the strap, but I wouldn't know about that. Going back to this, we have the angles up here, and the big thing about the angle is that you're given 14 kilograms per metre. What I will do for you in the test is give you a number there. I won't make you calculate it like you had to do for the assignment. Just to recap on the assignment, everyone. You have to list the area of the angle and multiply it by the width to get the final, and multiply it by the number to get the final amount. In this one, you were given it and you'll be given it in the test. That is the length. That E is something that you have to calculate, and that means you have to calculate it between there and there. And to do that, you will need to look at a value called big T, which is 21.3, and that is that distance there, the width at the bottom and the width at the top. So 21.3 plus 21.3, the overall length is 533, so take 21.3 off that twice and you'll get the length of your angle. Lastly, the plate, and to be fair, the thing that students stuff up the most is with F, is what that number is there is actually 500, and they get it mixed up because the plate's called up as 250 by 500, and they get those the other way around. Of course, if you're having a bad day, the letter you don't want is N. You have to do the whole lot, yeah. And you compare that with the person that gets A. Life's sometimes not very fair. Yeah. I walk around and I see students doing different letters and things flat out, and then I see someone's got N and they've ignored it to the end, obviously. Or maybe it's nobody gets N, it's just something I've done. Okay, so we've gone over plates, we've gone over girders. The answers for that, if you're not sure of anything that's just come out of my mouth, the answers are all there for you. It's slightly different to the one that was the example that you did with me. Not that much different though.
So whether for the assignment, for the mass per weight for the angle, you have to go the length, the breadth, and the width, and then the number.
No, you don't have to do all that. You just have to do, you'll need another column with square metres. I put another column in for the assignment with square metres, so therefore it'll be the number times square metres times the width. Yeah.
Okay. Yeah. So basically, we're doing the length and the width, right?
No, the area and the width.
Area and the width. Okay.
Yeah.
Area and the width and the number.
I can't remember what I've called it up on the sketch. I think I've called it a width. Yeah. And the angle looks. Good question. The angle looks like this, right? And there's a couple of holes in it, I think, like that. So it's the square meterage times the length will give you a cubic metre. Where that is, just be careful, guys and girls. Don't get your millimetres squared mucked up with your metres squared. Remember, the final answer is in kilograms, not in grams. Yeah. Okay. Alright, with the reinforcing bars, the first one I'm going to do is the straight bar that comes down from here down to the bottom. Now I'll just go in on that a bit more. Obviously, to show that there's a lap, I've drawn one beside the other, but it's very hard in sketch format to do that 100% properly. So this is a straight bar that has got cover at the top, comes down and it overlaps to that point there. Okay, so let's have a look at the calc behind that. 1,000 minus the cover's 40, there's the cover up there. So that's 960. The number of bars, well, how wide is this abutment? The abutment is 3.7 wide. So it's going to be 3.7. In that direction, we minus the cover and the cover again. So that'll be 3,620. We divide it by the gaps, which makes 14.48. It's greater than 0.2, so we go to 15 gaps. And then, of course, that makes 16 bars. So there's 16 of them, and 16 on the other side too, the 1601s. I think if any of you get that bar, I think you're going to get that pretty right pretty quickly. I'm confident most of you should be able to get that one correct. Where it gets complicated is the 1604 and the 1603. Okay, so I'm going to show you something now which actually might make you think about the assignment as well, because you have a bar that is in a Z shape like that in the assignment. So when I ask you to calculate the U bar, and I tell you that it's that distance plus that distance plus that distance, right? That distance plus that distance plus that distance, so A, B and C. So So A plus B plus C minus the curve, remember? What was the name we gave that? The
40.
yeah, it's
40.
We gave it a name.
Bending allowance.
Take off the bending radius, our bending allowance here. So we'll call it BA, then minus BA. Alright? The trouble with most students is that when I change that to be like that, all of a sudden their brain goes to mush because I can just say, hello, Stu, is that you? Yeah, Roger just said our brains are mush. I didn't. I just said when you get that in front of you, it goes to mush. If I put, I haven't really got a bigger one of these, but we'll just use that for an example. If I bend that down like that, has the bar length changed? No, not at all, right? So really, it's from there to there, from there to the outside, and from there to there. And what students say to me is, no, that's not right, Roger, because you're taking into account this bar twice. But when you think about it, you're taking it into account twice here and here. And when that light bulb goes on and the mush disappears, it's actually very easy to calculate a Z bar. And that's where a lot of students go wrong in the assignment, because I think you've got one that goes along and down and along, and one that goes that way and backwards. You just change them all to U bars and see what your calculation comes to, and you know whether you're right or wrong. So that therefore means that we need to calculate from here to here, from the outside edge to there, which is an easy calculation, and then from here to up there, which is also an easy calculation. The hardest one involves the lat, but it really isn't that difficult either. So what we have is A, B and C. So to calculate A, it's the lat, which is 512, which is 32 times the bar, plus cover, plus the bar diameter. B, which is that one across there. Remember, we go from the outside edge to the outside edge. So B becomes this 800 up the top, but we also have to add the bar diameter to get B. Because if you take that 800 and shift it over to the edge of here, you've still got the bar diameter to go. So it's 816, and this one's easy, it's 350 minus the cover on each side, which makes 270. So when we actually add all of those up and take off the two bend allowances, we end up with 1574. And we can do exactly the same for the other one in the other direction. Lastly, second lastly, the actual U-bar suddenly isn't that difficult. We go back up to our master plan. The U-bar is coming down, along and up. That dimension is 350, that's 1550. So we just have to take cover off each time. And we end up with a U-bar that is 270, 1470 and 270. Minus the two bend allowances equals that. I guess the hardest one is 1606. Area A is 3700 minus cover minus cover. So let's have a look at 3700. So it's that height from there down to, sorry, it's the length. It's the length of the bar. Is somewhere it says the length. Oh, there it is, 3700. The abutment width. The abutment width is 3700. Therefore, the bar down here is 3700 minus cover minus cover. So we get 3620. That is the actual length down the bottom here, 3620. If we want to know how many of them there are, we'll calculate that in a minute. The length of the bar is 3700 minus cover. The number of bars that there are, well, area A has a height of 1 metre from here to here. So we have to take off, where is it? 1 metre minus, in this case, 80. Because there is no construction line. So take off 40 and 40. And we divide that by 250, we have 3.8, which equals 4 gaps, which equals 5 bars. 5 bars on one side, 5 bars on the other side. Coming down to the bottom part, where the bar curves round, this is the bit that's had the most controversy of all. And I'll just go over that one more time. It's where the bar starts. So if we have a bar that goes like that, the bar starts on that tangent point there. That is 2 times the diameter, 1 times the diameter, and the cover. And that's at both ends, and we start from the centre line of the bar when we do it to work out how many there are. And if you've done that in the assignment, then that's great. If you haven't, you need to take that into account when you go to the assignment as well. So I generally find that people, even the good ones on this, they take most of the time up to finish the test. So they don't really have time to do anyone else's work or whatever by text. There are going to be students that are going to be saying to me afterwards, the clock stopped. Please don't play with that devil. Try and forget it's there, but keep an eye on it, and try and finish, save your test before that clock counts down. I'm only saying that because I'm not sure the one you're working on last, what happens to it. The previous one saved, that's fine. But the one you're actually on, when it cuts you off, I've got a feeling that it goes back there. Because you're diddling around with it, trying to figure out what the answer is. I've got a feeling it goes to 0, like no answer. Yeah. So, yeah, at the very least, don't play with the devil as it's going tick, 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 tick. So that's the test. It's a little bit different, but if you understand reinforcing, it isn't really that tricky. You will need to go over those mathematical questions at least once before the test. It will be a reinforcing for an abutment, so it'll be in exactly that same format. The bar sizes will change, the lengths will change, but it's a format that you need to be able to do to pass the course. Remember, you don't have to pass each thing, you just need an overall mark of 50%. Alright, and some of you are well on the way. So you can fail this test and still pass the course, but you do need to do the test. You can't just not do it and hope that you're going to get enough marks. I have had a couple of students who have got 100% in this over the years. Not many. One or two. How many did you get, Grace?
I cannot remember.
Was it one of your bigger numbers?
Not sure.
Good answer. It was probably about 18 or 19, I knew.
Yeah.
Okay, so this happens every year before a test. I feel like I've just put a stick of dynamite in the water and all the fish are sitting around. Is there anybody got any last minute questions on that? The answers I'll make available right now, which are those ones there. So you can have a wee look through them. You might still want to ask questions. Otherwise, you've got the rest of the day to carry on with your assignment or whatever else you want to do. Shut up.